Let us now understand how to find phase shift of a sinusoidal function. We have three examples here, and I hope with these examples you'll exactly understand how to find the phase shift. Phase shift basically is horizontal translation when we are comparing the function with its base function. So that is what phase shift is. How much it shifts from its base function towards left or right. If it is shifting towards right, we say phase shift is positive. If it shifts left, phase shift is negative. Now, the three functions given to us are y equals to cosine of x minus 15 degrees plus 1. Second one is y equals to 3 sine 2 times x minus 75 degrees minus 1. And the third one is half cos 5 over 2x minus 75 degrees. We have purposely taken very different examples, but the concept is same, right? The concept here is this angle theta. So we are comparing it with cos theta or sine theta, for example, right? So when we are comparing our function with cos theta or with sine theta, right? Depending on what the base function is. So that is the base function for us. So to find phase shift, what we do is we just equate that theta. Imagine this is theta for us, right? So we just equate the factor inside to 0 and calculate the phase shift. That gives us the answer. Okay, so method is same. The equation could be very different, right? Here we have factored out 2. Here we didn't factor anything, right? So these three equations are very different in a way, but how to find phase shift is exactly same for all. And the method is we have to equate this part to 0. That means this should be equated to 0. Or what value of x will make this factor 0. That is what is going to give us phase shift. So let's do it. So x minus 15 degrees equals to 0. That gives us answer as x equals to plus 15 degrees. I'm purposely writing plus. It means this cosine function is shifted as compared to the original cosine function 15 degrees to right. So that is what it means. Now let's look into the second equation, which is y equals to 3 times sine of 2 times x minus 75 degrees minus 1. So for phase shift, we'll again equate 2 times x minus 75 degrees to 0. So what do we get? We get 2 times x minus 75 degrees equals to 0. Now this is equal to 0 if x is equals to 75 degrees, right? So there is also a movement towards right since this place is positive, so it is right. So phase shift of 75 degrees to right as compared to sine theta, the sine wave. So the last example here is 5 over 2x minus 75 degrees. Well, you know what to do. Equate that to 0. So we get 5 over 2x minus 75 degrees equals to 0. That gives us x value of 75 degrees times 2 over 5, which is 30 degrees. Correct? And this is also positive, so it also moves towards right. Now my question is, I've given you three questions here, all with a phase shift of positive. That means the function is moving to the right. I'd like you to give at least one equation where we have a negative phase shift, where the function moves towards horizontally towards left. That will be an exercise for you. Thank you and all the best.